Hi everyone, we are from TechJam, and today we are very excited to present to you our project PrivaStream. Let me start with a scenario. You're live streaming on TikTok, chatting with your followers, unboxing a packet, or walking through the streets. You're focused on your content, but in a single careless moment, your credit card flashes on screen, or your home address appears in the background, or someone in the crowd walks past with a visible license plate. In that instance, your private information is broadcast to the world. It is irreversible, unfiltered, and potentially dangerous. This is the problem we set out to solve. In the age of AI, what we share online is no longer just entertainment. It's our personal data and it's under constant threat. On TikTok Live especially, streams are fast-paced and unedited. Current privacy solutions work after the damage is done. That leaves creators vulnerable in real time. And so, we created PrivaStream, protecting privacy in real time, one frame at a time. First, let's talk about the complete flow of the system. Initially, a live stream is split into audio and video frames. The audio frames are transcribed to text by Faster Whisper v3, which is then fed into the Berta v3 model, finding and timestamping any spoken PIIs. In parallel, while the audio pipeline is working, the video models are also working, with our different models working in parallel, the mouth and faces blur, license plate, and on-screen text reduction. Finally, a sync engine uses the timestamps from the audio analysis to combine the redacted audio and video into a single secure system. Now, let's talk about one of the hardest problems we tackled, audio privacy. We started with high-quality PII datasets on English essays from Kaggle and built our own dataset of around 2,000 samples, combining to a total almost 70,000 samples that we trained. Here's our training configuration for the Berta. We train models across 4 folds, plus several full-fit runs, consistently labeling 13 categories of PII. To improve diversity, we developed 4 key variants of the Berta v3 model, namely the multi-sample dropout model, which stabilized training, bidirectional LSTM model for sequence modeling, knowledge distillation model using the teacher-student setup, and lastly, data augmented model. For our knowledge distillation model, we developed a custom formula to compute the student loss with KL divergence against teacher logits. This gave us softer targets and improved generalization. Furthermore, to improve accuracy and to avoid overfitting, we built an ensemble of 10 models across 7 groups using weighted folding, with group weights optimized by Optuna using an auto-fold cross-validation. The result, our Berta v3 ensembles hit 96.988% precision and 98.34% overall classification, surpassing prior state-of-the-art benchmarks. Here's our ensemble Berta results. Our final model was the result of rigorous experimentation. Here are some of our unsuccessful fine-tuning approaches. Finally, to achieve low latency, we combine Silero V80 to filter silence, cutting compute by up to 60%, Faster Whisper for transcription, which runs up to 4 times faster than OpenAI Whisper model, while keeping the same accuracy. On the other half of our system, video privacy, which consists of mouth blur, faces blur, license plates, and on-screen text reduction. For license plate detection, we use the Singapore license plate dataset from RoboFlow Universe, providing nearly 9,000 pre-annotated images. For our license plate detection, for our text reduction system, we use the ICDA R2015 dataset, which is a standard academic benchmark designed for reading text in a complex, uncontrolled environment similar to that of a live stream. So, Let's deep dive into our first model. Whitelist face blur using inside face framework. The core principle is to keep the creator clearly visible while protecting the privacy of everyone else that appears on the livestream by blurring their faces. Each time a face shows up in the livestream, the embeddings of the face are then computed, and it is then compared to the creator's original embedding using cosine similarity, and we use EMA to continually refresh the embedding. To prevent a distracting flicker effect, we built in several stability features using the hysteresis thresholds and M of N folding. By precisely identifying the creator's facial landmarks using inside face, the system can also blur the mouth region at the exact timeframes our audio pipeline flags spoken PII. Next is a license plate detection. We fine-tuned a YOLO V11 model. The key to its high accuracy was our aggressive data augmentation strategy. We didn't just train it on standard images. We programmatically stimulated real-world challenges by adding motion blur, glare, random scaling, and HSV jitter to the training data. This system is tuned to minimize false positives since it is the most costly. For maximum performance, the final model is exported to ONNX format with options for TensorRT optimization. Using temporal stabilization, if the detector momentarily loses sight of a plate, the tracker's prediction fills in the gap, which extrapolates the bounding box for several frames. Our final video production layer is on-screen text reduction. Our system is trained to find text in the video, read it, and determine if that text is sensitive. Once text is located, we need to classify it using a logistic regression classifier. We engineered features using TF-IDF factorization with character n-grams to capture the unique patterns present in different types of PII. Our primary model for OCR is called Doctor, which uses FAST for text detection and MobileNet for text recognition. This combination is incredibly effective at reading text in complex natural scenes. Our license plate detector achieves over 97% recall, and our PII OCR pipeline is even more robust, with a recall of 0.9869 and a precision of 0.9701. Now let's go on demo. Let's start enrollment. Here's my friend William, and he's going to enroll his face. The left stream is the streamers and the right stream is the viewers. So streamers can accidentally say important information, and so here we are going to show an example.
My password is 123.
Also, here is a mock identity card. Do you hear the PII? No, right? And here's the license plates. And here you can see the information of the identity card as well as the license plates. Last but not least, our system is built for the cloud, where a single Azure H100 GPU node can process 15 to 20 full 1080p streams concurrently. This GPU pools are designed to auto-scale to meet any demand. It's also incredibly fast. Video reduction happens in about 150 milliseconds per frame, and the entire audio pipeline completes within 4 seconds per utterance. This is all supported by modular microservices. Here are the sources that we use for our work and research. Thank you everyone for listening to our presentation. PrivaStream turns TikTok Live into a safer place for creators and audiences, protecting privacy one frame at a time.